Hi, my name is Bruce and this video is about making a custom worm. So this is the setup for machining the worm. Here is the worm blank. It's 24.02 millimeters diameter. That's just the geometry that I need, the size that I need. It is a 3-start worm with a pitch of 1/8 of an inch and a lead of 3/8 of an inch. So the change gears are set up to give the lead of 3/8 of an inch. It's going to be a bit hectic. It's in the 4-jaw chuck just so that I could dial in the arbor and then make sure that the ID and OD of the gear of the worm is concentric. The worm blank is keyed to the arbor, which is made specially. It's sticking out a lot because I want some runoff room for the tool. So I've got a live center. I just bolted on, there's an axial bolt to retain the gear blank, and I just put a center in the bolt after the bolt was installed, because every time you tighten the bolt it turns up in a different location and the center is not true. So you have to put a new center in every time you put a bolt on. The tool is ground to the geometry of the worm, which is a 40-degree included angle, a 20-degree pressure angle. There's a flat on the tip of a calculated size to match the form of the thread or the form of the worm teeth. I have a dial indicator set here to measure accurately the plunge or the infeed, which is the depth of the cut and the height of that will result in the height of the teeth, and I've obviously got a target value for that. The indicator hopefully more accurate than my rather crappy machine dials. I have the compound set at 90 degrees or parallel with the axis of the lathe so that I can index the tool for the first, second and third starts. I will leave the half nuts engaged the whole time, so I'll have to back out and reverse the lathe every time, but I'm leaving the half nuts engaged the whole time so that I don't lose my place for the successive first, second and third starts. The cut will be straight plunge in, which I think may be a challenge on this small machine, but it's quite difficult to use the half included angle method, set the compound around it, the angle of the thread or the teeth, because then the same problem of indexing for the second and third starts can be done, but it's rather more complicated, and I'd rather not have to do that. So I'm going to try a straight plunge, see if it will hang together. So that was just a scratch pass. Now to see if the lead is what I want. Looks pretty good. Seems happier at the lower speed. That's probably 100 RPM or something. So I'm down to 3 thou of advance each cut because the lathe is pretty much at its limit. Okay, so that's taking pretty much nothing off, so hopefully that will do. Next step is to move the tool, to index the tool along the axis to the second start. So now the plan is to shift the tool along the axis by one pitch to cut the second thread or groove, I don't know what you call it. The compound is locked up, so I'll unlock it, use a dial to move accurately 125 thou, 1/8 of an inch, and lock everything up again. It's 125. Now just a test run with the tool away from the work. Stop it halfway and it looks, the camera angle won't show it, but it looks to me like it's 1/8 of an inch from the first groove, which is exactly what it should be. So there is a scratch pass, you can see the mark right there, which should be exactly 1/8 of an inch from the center of the first groove, and there should be room for one more next to it. So it looks about right. So you won't see on the camera angle, but with the caliper set at 125 thou, it looks pretty much bang on. I'm backing the tool out every time I move back to the start because of backlash. If I reversed with the tool in the hole, the amount of backlash would move it over and it would mess up the hole and it wouldn't cut. Okay, so that's the second pass done, second start or second thread, and I will say that I messed up. I started the lathe from back at the start position, but without switching it back to forward, and so I crashed the tool into the center. That moved the tool in the axial direction, so everything is ruined. The tool is no longer going to cut the correct path. Not entirely. So what you can do is manually bring the tool back to the thread and then using the compound, get rid of the backlash, use the compound and a magnifying loop, and then just push the tool into the thread and move the compound back and forth until it's a perfect fit. And then the tool will be back in the right place with an error of a couple of thou probably, but at least it's a recovery position that you can take. So there you go. So now I'm set up on the third pass, third start, and one scratch pass, and off we go. One interesting point is that I lost a few thou every pass, meaning a touch off I had to feed in a few more thou each time, and I'm wondering if that was tool wear. So here's the worm cleaned up and deburred. At surface, on the surface it looks pretty good. You can see the three starts, this kind of lobed appearance is where each thread or groove or tooth starts. That's as it should be. The gear looks okay, but there is a problem, and what happened is the tool did in fact wear, and the bottom of the groove in between the teeth is not flat. It is on one thread, but then the tool wore, and the next two threads have a kind of a quirky profile in the bottom of the groove. So here's the tool, and I don't know how easy it is to see, but the tip was pretty much square, had a flat tip, and now it's kind of rounded. So that's the end of the tool, and you can see just right on this corner there's a shiny bit, and that's the wear where the tip is worn off. So I'm trying to show here the bottom of the groove. In this groove here, the bottom of the groove is quite square, but in the next two there's kind of a shoulder right in there, and that's where the tool wore. Now, it's not a problem except if the mating gear tooth goes down in the bottom there and hits that little shoulder there. And there's about 0.25 millimeters of clearance between the crown of the worm gear and the bottom of this groove in the worm, and that could easily be that tall. That little shoulder there could easily be that tall, so I think I'm going to need to clean that up. So I put the worm back in the lathe and just cleaned out that little shoulder at the bottom of the thread form, of the tooth form, and you can see just in there's just a fraction left. But I think that's enough. Now I will not have a problem with the crest of the worm gear bottoming out on that little shoulder. I did not want to take any more off the flank of the tooth, so I just sharpened the tool so that it would fit in here and reach the bottom without touching the flank, and just skimmed the bottom. So I measured the worm with wires as if it was a thread to try and measure the pitch circle diameter. Bit of a struggle as the lead is quite severe, and it came out to a pitch circle diameter of 21.7 millimeters, and it should be 22, so that's 0.3 millimeters different, which is pretty disappointing. That means that there's, if you do the geometry, there's 5/1000 of an inch of backlash, if you will, on the axial, in the axial direction. essentially the groove is too deep. So in the setup that I'm using this for, it's a fixture. I'm able to adjust the center distance between the worm and the gear, so that I can push the gear down into the groove of the worm and take out that backlash a bit. But then I might run into clearance at the crest of the gear teeth. So let's see. So there is the worm in action. It's assembled in a fixture. You can see the gear in the front and the worm in the back. And I must say it works pretty well. And there it is from the other side. So that's it. I hope you have found something interesting in this video. Bye for now.